All right, hi, linear algebra. Um, all right, number one. Here's number one. This is the transformation T. I just wrote it in vector form, and what I'm doing here is going through the conditions of linearity, okay? Here's the first condition. Check to see if K times the transformation equals the transformation of K times the vector, okay? And I just made a note that this, same thing as this. And here all I did was I just worked through K times T and T of K times V. And I saw that, oh, they are not the same. So T is not a matrix transformation or a linear transformation, okay? Number two, I proved this using a 3x3, all right? What I did here was I showed A transpose, A. And look what happens when I multiply it out. Okay, look at the black. And I'm going to talk about here how this is where you could get very intimidated by the algebra, but look at the green. Okay, I am moving down column 1 and finding the determinant. Actually, I just noticed something. A notation here should be, I should say that I'm finding that I should add right here, boys and girls, that now this step is me finding the, like right here, there should be a determinant symbol, determinant of, okay, this whole thing, and then similarly here, determinant of this whole matrix, okay? All right, so here, look at the green. This here in green, I got to, I'm going to shrink down a little bit. There we go. All right, that there in green, this is just moving down column 1. This is just my first term entry, right? This is just my first movement. It's this entry times the determinant of the remaining 2x2 diagonal minus diagonal. And this is what this is in green, okay? And I put a dot here, as you'll see, because I want you to see something, right? This green is just, like I said, the first entry here when I cross. Similarly, this green here is just the first entry here, right, times this determinant, all right? And what I want to show you here is it's something that really nice happens. Again, you know, I mean, I don't know that I want to spend a whole lot of time on this, because if we spend so much time on talking about the algebra, I think we're all just going to go crazy, and that's not really the point. But one thing I want you to notice is, look at this, what's in this parenthesis right here. That's the first breakout, this right here, okay? Do you see how if I were to FOIL this thing out, right, I'm going to have somewhere a term that's d squared g squared. I'm going to have somewhere a term that's e squared h squared, and I'm going to have somewhere a term that's f squared I squared. And they're all going to be negative because of the negative here. And you'll notice here that if I were to FOIL all of this out, right, I'm going to have a d squared g squared somewhere. I'm going to have an e squared h squared somewhere. I'm going to have an I squared f squared somewhere, okay? So, in other words, I know that already those three pairings of terms, the positive d squared g squared from here and the negative d squared g squared from there, it's all going to cancel out, all right? All that's going to cancel out. Now, I did not say that everything in here canceled out. That's not what I said. But if I were to just kind of look at this for a second, I notice a couple of things, right? Maybe you'll even think a little bit more to yourself, like, huh, okay, so I know like the d squared g squareds cancel out, but maybe you'll go over here and do some number playing, okay? And let me just go up here and just write this out. Okay, because the point of us is to, you know, sometimes we will need to go into the morass of algebra, but then where we don't need to, let's just take stock and kind of practice this, just kind of like problem solving, like intellectual problem solving, right? All right, so I know that if I multiply dg times dg, that's going to cancel. How about dg times eh, okay? Is that going to remain? Will that be canceled out by something in here, right? Will DGEH remain? The answer is yes, okay, because you can look ahead to these two trinomials. When you multiply these two trinomials out, every term is going to be a degree 4. It's going to be some letter squared times some letter squared. So what that allows me to very quickly do here is figure out and see that if I multiply this all out, what's going to be left behind and what's going to stay. All right? Similarly, when I multiply these two out, I can very quickly and efficiently figure out what's going to be left behind and what's going to stay. That goes for here, and that goes for here, okay? I actually am not going to do it right now, boys and girls, okay? If you really need me to, I mean, I can, but when you do that, right, with this is just the first term here. It's just taking this first term when I move down column 1. You're going to notice something. And what you're going to notice, well, you're going to notice that things clean up awfully nicely, right? And when you move to the second term, you'll be able to most efficiently figure out what this expression is fairly quickly, okay? And the point is, at the end of the day here, you will see that these expressions are both equal, okay? All right. Number 3, here's this one. Here's K times A, and here's the matrix A. Left-hand side here, I figured out what the determinant of KA is. And here's the determinant of A on the right-hand side. And what I notice with just some mild algebra is that, oh, the determinant of K times A will equal just K cubed times the determinant of A, because what's remaining in here is the determinant of A. Okay? This one was hard, number 4. This is if you really wanted to challenge. It said to somehow show that this equation here, this is an equation. This is an equation that involves a determinant. Somehow this will become, right? This is synonymous with the linear equation that we knew and know. It's y equals mx plus b. Somehow, some way, this becomes this. All right? So let me talk you through. So I was talking to Layla about this, and I said to Layla, so Layla, what do you think is the first thing you do? And she said, I mean, I'm looking at this equation here, and I'm saying I want to get rid of the determinant. I want to get rid of a matrix entirely. For me to make this all look like this, let's just get out of the determinant and get out of the matrix. And I agree with her. So here's me moving down column 1. Whoops, sorry. That's me moving down column 1, okay? And you'll notice when I moved down column 1, I made a couple of notes to myself. I made a note to myself that this right here in green, because x1, y1, x2, y2, those are just points, right? These are constants. So I know that this is just going to be a number. It's going to be a constant. I'll call it b. And I also want to look over here and keep track of what is x, the variable, versus a constant x sub 2 or x sub 1. So I just highlighted the variable x. I highlighted y, okay? And then what I did was, next line down here, I just distributed the -1 to these two terms and broke out the parenthesis here, and I have this. And then what I did was I combined like terms. Look at that, because this is just xy2 and xy1. When you combine at negative xy2 and positive xy1, we get this right here, right? Okay. Negative x y1 minus y2. Whoops, I have a sign swap. Sorry, I just got a sign mistake. This should be positive x. Okay, positive x times the quantity y1 minus y2. Okay, and then what I did was, then I just, I isolated this equation right here for y. So I subtracted over this term, so minus x, y1 minus y2, and I did subtracted b, right? Then I divided both sides by x2 minus x1, this equation, and I get y equals negative y1 minus y2 over x2 minus x1 minus b over x2 minus x1. And I said to myself, just notice this is just a constant. This is just a number, right? Well, I took this negative and distributed, and I got y2 minus y1 over x2 minus x1 is times x minus k. And this right here is slope. Slope. And what we have now is this equation is just y equals mx plus b. I mean, don't get hung up on the plus, the minus here. The point is that this number is just some constant, whether plus a negative constant, plus it's just a constant, okay? That was hard. That was good. 5, sorry, a wordo. It was a word typo on your paper. I want you to show that this matrix is invertible, not singular. Singular is the opposite of invertible. Show that this matrix is invertible. And to show that a matrix is absolutely invertible in the context of the determinant, you know that the determinant must not equal 0. If a matrix's determinant equals 0, it is not invertible. So I just traveled down, what did I do? Oh, I went down column 1. Okay? So the determinant of A is me traveling down column 1. And I notice that, hi, Mr. Logue. You want to say hi to my linear algebra class? It's Mr. Logue, everybody.
Hi, linear algebra people.
And you notice that sine squared theta minus cos theta times negative cos theta becomes sine squared theta plus cos squared theta, which you know always equals 1. So it is literally impossible for the determinant to ever equal 0 in this case. Okay? And that is the proof of that. And then number 6, I don't know if any of you saw it, but number 6 is very similar to question number 3 above. So I said for number 6, see the work for number 3. See the work for number 3. See the work for number 3. Okay? Goodbye. Thinks you're all so cute. Go ahead, Mr. Logue. He just said,
I didn't
aw.
say that.
Well, he went, aw. Wait, where are you going, Mr. Logue?
My bagel.
Wait, why are you saying aw?